We are looking to enhance the Connect 4 project from the YByte Python curriculum available at www.ybyte.in. In the previous video, we looked at a variation that we called as anti-Connect 4, where basically, the fact that computer is playing randomly became a strength than a weakness for the computer. In this video, we will look at another variation, which is called the pop-out version. Now, interestingly, unlike the anti-Connect 4, this is not a creation, let's say, that I am making. In fact, this was proposed by the original makers of the game. They have a board which allows you to pop out. So what does pop out do? Well, pop out, both the player and the computer, which means both the players have this choice that they can play the coin from the top as the regular game, which is what we have been building. But there's also an option to pull out a coin or pop out a coin from bottom. Again, this is best explained through an example. Basically, let's say we have a situation where we have these three in a row, in a single column, sorry, these, let's say blue, red, and blue. Now, if it's a blue's chance, since the blues column is on the last, in the bottommost row, blue can choose to pop it out. The moment blue pops it out, well, I will have a situation where this would have gone and the other two would just fall. So that becomes one chance. Recall in the original game, everything happens, a coin is put from the top, but here we can pull it out, which adds another dimension to the whole, game. Now we'll see how we can build this within our framework because it's a nice one, and implement all of this, like I said, within our framework. But some things to keep in mind. First thing first, we need to have a very clear indication to the player that, look, this is a pop-out version and hence pop-out is allowed. Now, for both the player and the computer, we need to figure out which are the columns on which the pop-out action can be used. Now, basically, these are columns on which the lowest row, which means row number 5, is the present color. So for the player, it's going to be red coin on the row number 5. For the computer, it's going to be a blue coin on row number 5. So you need to figure out for both of them which are the columns where the pop-out can be used. For the player, remember the player plays the game by clicking on the screen. So we need to add an option to say, okay, look, if I click on this particular part of the screen, it's going to be a pop out. So the way I'm going to do this is that, look, I'm going to say when I click too much to the bottom, basically under the, the board, then that's a pop out. So in that column, I can pop out. In the computer choice, we are going to just randomly pick a pop out, and you're assuming pop out isn't possible. So we're just going to randomly do a pop out because, remember, computers playing randomly anyway. Um, and then there is a very interesting thing that comes up is that, look, now we have a situation where on a player chance, the computer can win, and a computer chance, player can win. Let's see how this can happen. Let's say, hypothetically, we have a situation where, we have these three as red and these two are blue. Now, it's blue's chance to play. Obviously, this is not a good move, but it's possible, and hence we have to program for it. Blue goes and decides to pop out. Now, the moment blue pops out, notice this was blue's chance. The moment blue pops out, in fact, red has won, which means that even though I'm playing for the computer, I must check for the player winning also. And likewise, when I'm playing for the player, I must check for the computer winning also. Unlike earlier, where you win only on. Now, let's see how all of this gets done by writing some code. So let's start from here. Remember, we have previously we had a version called anti-C4. So I'm going to set that to false because that's not what we're building here. In fact, in the similar spirit, I'm going to create a flag called pop out, and I'm going to set that to true. The idea is that, look, this is the pop out version. Now, in order to tell my player, I'm just going to have a condition here. Look, if anti-C4, well, if that is the case, then, write, for example, A. And let's say if say pop out, so if it's the pop out version, then again I will tell my player to write a P, for instance. So when I, let's say, do this, I just tell my player to write, let's say, a little bit lower P. Again, this is just a choice. Of course, this has to be P. So there's absolutely no ambiguity that, look, we are playing the pop out version and hence pop out is going to be allowed. Let's just see this in action. When I run this piece of code, you notice there's a P written here, which very clearly indicates that, look, pop out is active now. Now let's build this feature for the player first. Remember, player plays the game by clicking on the screen, at which point this function play xy gets triggered, and we figure out which column we are playing in. If that column is available to play, then the game proceeds. Otherwise, the player has to basically play again. We are going to maintain the same structure, but obviously we're going to change a few things over here. You notice that now I need to figure out which column the player is playing it, that is all okay. So that part is okay, but I need to figure out which are the available columns. I will also need to figure out which are the available columns in which I can pop out. So I'm just going to say, well, pop out calls. Now remember, these are those columns. So I just say find, let's say, pop out, say OUT calls with value of 1. So basically, I'm just going to find out, look, what are all those columns in which I can pop out where the player's coin is on the bottom row. So let's just define this function, before we move forward. So I'm just going to say def, let's say find, say pop out calls, and I'm going to pass an argument into this. Like I said, really, this is not hard. All those columns on which I have, let's say, that color, that value at the last row. So I just go and say PO calls is, say, an empty list to start with. For KK in range N calls. So basically, search through every call, basically go through every column. If, let's say, board N rows minus 1, the last row, KKth column is equal to the value, that means that this column can be popped out. So I just go and say PO calls dot append, say this column, right? That is KK. And of course, having done this, I will return, let's say, okay, return PO calls. Now let's just put a small comment over here, say columns that can be popped. Now, now, before moving forward, notice that now there are two possibilities. My player may want to pop out. My player may want to just play the regular game. So I need to decide whether to proceed into this loop. I also need to decide what to do once I get in. So for this purpose, I create two Boolean variables. I just go and say a Boolean, for this purpose, I create two variables, one a Boolean. So I just set this to, let's say, call in available calls. Basically, this is exactly the same as this. So I find out, okay, look, if this column is present in available calls, however, remember, if I am playing pop out, so if the pop out variable has been set, so I just go and say if pop out is, let's say, set. Now, in this case, the user has an option to pop out, provided in my game, if the user goes and clicks, let's say, below the board. So I just go and say, look, if y less than minus 100, which means the user pop out demanded. Now, if pop out is demanded, well, I will proceed provided the column can actually be popped out, because I must click on a column which can be popped out, right? So in the same, so basically I just go to say call in, let's say, pop out calls. Now this makes sense. Basically, now I'm going to proceed. If the column is available to play, I check if the pop out, if the user is requesting for pop out, then I check, well, is this making sense? Can I even pop out from here? However, if the answer is, let's say, yes, if I do move on here, my action would be pop. So that's the name I'm giving for the action. And basically that's it, right? Now this code is very neat, very concise. It took me some time to come up with it because it looks like there are too many combinations, but this really captures it. Think through it. If my pop out is not set, basically I move as usual. If the pop out is set, if the user is requesting pop out and I am in a column that can be popped out, again I proceed, but the action is pop. So here I'm going to replace this with, let's say, proceed. And now I'm just going to ask myself a question. Look, what is the action that I require? If I require the action to be regular, well, it's exactly same as what I was doing earlier. So if action is, let's say, regular, well, in that case, nothing changes. I just go and say, look, I find out the lowest row in the given column, that in the column that's been chosen. On the other hand, if it's not regular, I must do the pop out action. So I just say pop out action. Now this can be done through a for loop quite easily. Just have to be a little bit careful with indexing. So I'm just going to say for KK in range n rows minus 1 all the way to 0 in steps of minus 1. So basically I'm going from the bottom row going all the way to the top, but I'm not touching the final row because and this will become clear from here, right? I'm just going to say board, say KK, and call is equal to board kk minus, so board say kk minus 1 and call. So that will create the pop out action. And at the top row, at the top out of the row, I'm just going to say, well, board 0 and that call, well, it must become a 0. Even if it was filled up, now it will be a 0. Think through this. Think through this. Basically, this is just bringing out each call, each row down and making the top one empty. So this is the pop out action. Now, just to make sure that this loop actually works, I must in fact set my action to regular in the usual case. So think through this. Very nice code. Like I said, it did take me some time to come up with it, but I think quite clean right now, right? So by default it's regular, but if the pop out is set up, then I may pop. We will just test this much of the code because we just want to make sure everything is okay. In fact, everything else can pretty much remain the same except this one thing, that remember now, um, even though the player is playing, in fact the computer might win. So I can just add another condition over here before I search for everything is done. Let's say I can add elif, say check winner, say check winner 2, because computer might have won even though the player is playing. This has to happen only in the pop out situation, uh, but it's fine. So I can just write like this again: game over is true, computer wins, and I write the result as 2. So think through it. Too many conditions gets a little bit confusing, but let's just test this in action. So okay, so when I play this, now computer has made the first move. I just want to test the pop out action. So let's say I go and click below. You notice one row got popped out. Um, okay, so this time computer won. So let's do this again. Let's say I play here, I play here, I play here. Now, obviously, I should play here to win. But let's just say for the sake of demonstration, I play my coin over here. I play the coin over here. Now I can go and pop out on this row. This column doesn't really help me, but anyway, if I pop out, you notice everything moved down, and that's exactly what we are looking for, right? In fact, I can pop this out again. So that, because I clicked here, that kind of introduce a coin here, but I can pop this out and I will, I'll wait for the computer to, let's say, so I'll just play, let's say over here. I'm hoping the computer will play on this column so we can see a situation where I play and computer wins. Let's just try to play it. Okay, so exactly the situation I wanted. So notice if I pop out now as a player, in fact, the computer is going to win when I do this, and that's exactly what happened. So when I did this, computer won, the game is over. So very interesting. I played, but the computer won. Now, having done this, in fact, we can now go and enhance this for the player as well. I'm sorry, for the computer as well. So I just come to now. So just like earlier, I say, well, let me find out which are the columns available to, let's say, pop. And, so I just say find, say, pop out calls, let's say with value 2. Now, in the case of computer, basically we always sort of move forward. I am going to just set the action to regular by default. In case, however, it turns out that I can indeed pop, and I would know this by saying that, okay, like if len of, let's say, calls available, so calls available pop is, so that's not lem, len of, let's say, calls available pop is greater than 0, which means there is an option for me to pop. I'm going to say, well, for 50% chance I will pop, right? So I just go and say random dot random, for example, is less than 0.5. Just between 0 and 1. So if it's 50% chance, if it's indeed the case, I'm going to set my action to pop, which I think is quite reasonable. Now, having done this, I ask myself a question: if action is equal to, let's say, regular, then everything proceeds as usual. So I ask myself, okay, fine. If length of columns is such so and so, I will go and play, the coin on top here. If it's not regular, because again, remember, it will always take a value, so it's regular. If it's not regular, it will be pop. Again, think through this, quite nice. Well, I am going to basically do the same thing as I was doing earlier. This time round, I'm going to just say call is equal to random dot, choice, say calls available for popping. So I'll just pick up a column that's available for popping, anyone. And in that column, I'm going to do the action that of, let's say, so for KK in range, n rows, -1, 0, and -1. Well, basically, board, say, KK call is equal to board KK -1 call. So that's precisely the the uh, mm, so that's precisely the the popping action. But of course, the top row must be made 0. So board, say, 0, and call is indeed 0. Think about it. Little confusing, but if you go through it logically, it makes a lot of sense. As always, during a computer chance, the player might win. So I'm just going to add an elif over here. So elif, let's say, check winner 1. So even though it was a computer chance, player 1, well, I'm just going to take, let's say, this over here, and I'm going to say, well, look, player uh, player wins, and let's write result as 1. Now with this, we are ready to test this whole thing. In fact, everything is set up over here. um, all right, so let's say I start playing this. I'm hoping the computer will pop out somewhere. Okay, so let's not win this just yet. Okay, notice the computer decided to pop out, because it's picking up randomly. It popped out that particular coin. All right, no problem. So I will, okay, let's try to, all right. Okay, maybe I'll play this here. Computer decided to pop out again. I do this, and in fact, so there's multiple things that happen. I played here, computer popped out, and I won, and that's how the game goes. So very interesting, this variation. Lots of possibilities. But important at this stage to sort of reflect on how we analyze the entire situation and how we then added that the new feature into the code that we have. Very interesting, very logical, very nice way to look at programming, because this is how systematic thinking builds up. In fact, this is exactly how we learn programming at YByte. Look at our website www.ybyte.in, because we have lots and lots of activities that you can learn from. Take care. Thank you so much. Bye bye.